In the last video, we put together our first real trait. It has a few functions that actually do things, but we haven't really done anything with self here. You can see we just take this reference to self, and we're actually not doing anything with it. We're not. We don't know what type is going into self. We can't say like. We can't say self.health plus equals 10 like you could with a struct, because we don't know what kind of types are going to implement this. So it's pretty limited. And so the question is, how do you use traits to start modifying self? And the answer is it's kind of like the same as generics that we looked at in functions. What you do is you give Rust a promise that you're only going to give it, certain types, things that implement certain traits. And I'll show you, here's an example of Rust complaining. If you want to say, we have this attack with sword, opponent health goes down, that's fine because monster has this, has health, which is an I32, and we can do all that. And then let's say you are now in this condition. And then let's see, we want to print self, and that will not work because Rust is going to say, hold on a second, I don't know what kind of self you're giving me. Does it implement debug or not? You've not guaranteed that you're going to give me something that implements debug. You might just give me a wizard, and wizard does not implement debug. So it gives some advice here, and that is one way to do it. So you can go through, every time you write a function inside a trait, you can think of, what needs to happen here. And this where we looked at before in generic functions. And here we say self, which is the the type that goes in there, debug, and actually standard format debug, because we haven't imported it yet. And if you do that, then it will be just fine with that until, we start to actually try to use wizard. And now it's saying, down here, hey, wizard doesn't implement debug. So that's fine. So we rectify that and say derive debug. And we can do that for Ranger as well. And let's see if that is enough. And so there you go. You are now in this condition, wizard, because wizard has, there's nothing inside there, but we have successfully done something with self. We've printed out the thing that we gave it, and the way we did it is we said we guarantee that when we print this out, it's going to be a type that has debug. And that is one way to do it. One other way to do it is you can do it over the whole trait. Let's import debug now, because it's prettier. Use standard format debug. And so now with this this fight close trait, we're going to say anything that goes in here is going to need debug. Let's take it out of Ranger for the moment. And the way you write it is colon, and then the the trait that needs to go in there. So let's see if this has worked. And there you go. Yeah, so it's complaining about Ranger because Ranger is we're trying to implement it for Ranger. So let's uncomment that or recomment that, and there you go. Now it's working again. So anything that implements fight close is going to have debug. And if you want to add more constraints, then let's see, where's one? Where's clone again? Standard clone. So let's say we also want them to clone. And so you add these by adding this plus sign here. So let's just use standard clone, and then we will. So you see this sometimes in trait signatures where you want everything to have this plus this, and then we can say clone debug And the order doesn't matter, of course, clone debug or debug clone. And we will make them both clone and debug. And now the trait works again. And you see this, it depends on, it's always up to you if you want to put the constraint in the function or, after the trait. And in Rust, you see a lot of this, let's see, like clone itself actually has a constraint, and its constraint is called sized. And we talked a little bit about sized before, and that is like, how a stir is, this is not sized because actually a stir is not sized, which is why we use a reference to read it, because a stir could be this length, it could be this length, it could be this length, it could be anything. Whereas something like a string or any struct you make, Rust always knows the size of the type on the stack,